Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular video is November 2018, Paper 2, Higher Tier. Now, with the new specification being new, Grade 9 to 1 past papers are like gold dust, and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback, and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. Question 1. What does A intersect B represent in the probability of A intersect B? Circle your answer. Well, I think I've given it away there really. I'm just decoding what these things here represent. A intersect B, or this symbol here, means the intersection of. It means that an element lies in both sets. So if I had a set A and a set B, then the intersector are where they overlap. So it's that bit there inside there. Okay, so that's what that part there means. It means the intersection of. So A means set A, B means set B, the upside down U means the intersection of. This bit here means the probability of. So it's actually asking what's the probability of an element being in that set. Okay, but the A union B part is it needs to be in A or B or both. No, not that one. In A but not B? Nope. Not in A and not in B? Nope. It's in A and B. It's got to be in both. So another way of reading it is that is and. Question 2. P is 4, 9 and Q is minus 2, 1. Circle the midpoint of PQ. Okay, so if I was just to quickly sketch what this looked like, 4, 9 would be a point somewhere like that, 4, 9. And minus 2, 1. Minus 2, 1 would be something like there, wouldn't it? Minus 2, 1. Okay, so the midpoint is going to be somewhere around there, I suppose. Now there is a formula for finding midpoint. If this is x1, y1, and this is x2, y2, then my midpoint is going to be my 2 x coordinates added together, divided by 2, and my 2 y coordinates added together, divided by 2. So in this case, that is equal to my x coordinates added together, 4 plus negative 2 over 2, and the y coordinates added together, 9 plus 1 over 2. It's basically you're averaging the 2 out, aren't you? And that's equal to 4 plus 2 is 2, divided by 2 is 1, and 9 plus 1 is 10, divided by 2 is 5. Okay, so the midpoint then is 1, 5. Is that one there? Question 3. Which one of these is a geometric progression? Circle your answer. Okay, now a geometric progression has what we call a common ratio. So it will be a number sequence of the form A, AR, AR squared, AR cubed, where A is the first term and R is what we call the common ratio. Okay, so basically the next number has to be the same multiple of the one before. Now this first sequence is not a geometric progression, it's an arithmetic progression because it's going up in just 2's each time. It's the same jump. Okay, so that is not a GP. This next sequence, 1 times 3 is 3, 3 times 3 is 9, not 6. This is plus 2, plus 3, plus 4. This looks like a quadratic sequence to me. Okay, it has a common second difference, doesn't it? Okay, so that's a quadratic sequence. 1, 4, 9, 16, 25. I don't know if you recognize these are the square numbers, aren't they? Okay, so that's the sequence of square numbers. This last sequence, the first term is 1. The second term is 3 times 1, which is 3. The third term is also times 3. Look, 3 times 3 is 9. 9 times 3 is 27, and 27 times 3 is 81. So this is the one which is the geometric progression. Question 4. The bearing of A from B is 310 degrees. Circle the bearing of B from A. Okay, now you need to get it clear in your ofs and froms here. The bearing of A from B. So that means we're leaving B and we're going towards A, and that is a bearing of 310. Okay, now basic bearing 0, 0, 0, 0, 9, 0, 2, 7, 0, 1, 8, 0, 2, 7, 0. So 310 is going to be kind of off in that direction then, isn't it? Okay, so if I've got a point B down here, then my point A is going to be off in this direction up here. Okay, giving me my bearing from north of 310 degrees. Okay, so what is the bearing of B from A? So if I was at A and I wanted to go back the other way, then the bearing I'm looking for is this angle here, clockwise from the north line. These two lines are drawn a north right then on the top. Okay, so what is that angle there? Okay, well, if you have a look at this angle here to start with, angles at a point add up to 360, so that one there is 50. And actually what I've got here is a pair of parallel lines and a line crossing them, because these two are parallel. So that angle there and that angle there add up to 180 degrees. We call them supplementary angles, don't we? So then that means that that angle in there is going to be 180 minus 50. That is 130, is that one. Question 5. A circle has a circumference of C and a diameter of D. C equals KD. What value does the constant K represent? Well, the constant, normally C, circumference, is equal to pi times diameter, isn't it? So this pi here must be the same thing as that K there. So we're saying, I'm saying it's got to be pi. Question 6. Here is some information about 20 trains leaving a station. So we've got a number of minutes late. The first group is between 0 and 5 minutes late. The second group between 5 and 10 minutes late. 10 to 15 minutes late, and more than 15 minutes late. And we can see that 12 trains were between 0 and 5 minutes late. 7 were between 5 and 10. 1 between 10 and 15. And none were later than that. Okay, so you can see that there's a couple of extra columns on that table for us to complete. Now we're being asked to work out an estimate of the mean of these. So what we need to do is first find the midpoint, which is handily already been indicated here. So the midpoint of a range, you just have to add the two numbers together and divide by 2. So 0 plus 5 is 5, divided by 2 is 2.5. 5 plus 10 is 15, divided by 2 is 7.5. 10 plus 15 is 25, divided by 2 is 12.5. And we don't need to do the next one because there's 0 anyway, so no need to stress about that one. Okay, and then to find the an estimate of the mean, then we need to multiply our f values, our frequency, times our x value, whatever the values are that we've got. Okay, so we're going to use the midpoint as our estimate. So 12 times 2.5 basically. So reaching for a calculator. So 12 times 2.5, that comes out to be 30. 7 times 7.5 is 52.5. 1 times 12.5 is just 12.5. Okay, and then to find the estimate mean, we're going to have to add all those up, aren't we? So 30 plus 52.5 plus 12.5 gives me a grand total of 95. Okay, then, so an estimated mean is going to be sigma fx, the sum of f times x, divided by sigma f, the sum of the frequencies. So it's going to be 95 divided by the sum of the frequencies. 12 plus 7 plus 1 adds up to 20, doesn't it? 20 trains. So 95 divided by 20, 4.75. So we're saying on average there is 4.75 trains. Oh no, 4.75 minutes, isn't it? Not trains. In part B, it says the station manager looks at the information in more detail, and you can see that he's got a more finely divided up categories. So there's more categories. He's doing it every 2 minutes now instead of every 5 minutes. And we've got the new distribution in here. Okay, so he works out an estimate of the mean using this information. How does his estimate compare with that answer to part A? Is it going to be higher than part A, the same as part A, lower than part A? Not possible to tell. Okay, so if I look at our new data, I've got 12 trains, which is the vast majority of them, that before I thought were in the category 0 to 5, and now I've worked out in the category 0 to 2. So these are going to have a mid-value of about 1, aren't they? Giving me 1 times 12 there. And then the second category up here, I thought I had 7 trains that were in between 5 and 10 minutes late, give me a midpoint of 7.5. Now I see that those 7 trains are actually between 4 and 6, and the midpoint of those is going to be 5, which is again going to be shorter time than what I was using previously. And again, 10 to 12 is going to have a mid value of 11, whereas before I was using a mid value of 12.5. So it's going to give me a lower score, isn't it? Because I'm using lower midpoint values now. Now, question 7, work out the values of A and B in the identity. And I've got 5 lots of 7x plus 8 plus 3 lots of 2x plus 4 is identical to ax plus 13. Okay, so I've got quite a complex expression on the left-hand side of my identity symbol and a fairly simplistic one on the right. Now, when you've got identities, these are not like equations that you have to solve. We're not trying to move things over the equal sign and simplify it down. What we need to do is make one side look more like the other so we can more directly compare them. Okay, so what I'm going to do is I'm going to start off with one side, and it's usually best to start with the most complex of the two sides and make it try to make it look more like the other side so we can more directly compare. So let's start with the left hand side, because that is the most complex. So I'm going to write down LHS for left hand side, and that is 5 lots of 7x plus 8 plus 3 lots of 2x plus b. Okay, so we're just going to work on one side. We're not going to move things over. You'll get confused if you do it that way. So first off, let's simplify it by multiplying out the brackets. So outside the bracket, number outside the bracket gets multiplied by everything inside. So 5 times 7x is 35x, and 5 times 8 is 40. And the second bracket, 3 lots of 2x is 6x, and 3 lots of b is 3b. Okay, so I've got some like terms here. I've got 2 terms in x, 35x and 6x. So let's bring that together and make 41x. And I've got 3b plus 40. Now that's all part of my constant, isn't it? So I've got 41x's plus my 3b plus 40. Okay. Now we know that that is equal to ax plus 13. And now we're in a position I can more directly compare them. Let's have a look at this coefficient of x here. The coefficient of x on the left hand side is 41, and on the right hand side it's a. So if we're saying that these two things are identical, then 41 must be equal to A. Similarly, if I know that these two things are identical, then the number part must be equal as well. So my 3b plus 40 must be equal to 13. So if 3b plus 40 is equal to 13, then rearranging that, subtract 40 from both sides, and we're going to get 3b is 13, subtract 40, which is what, minus 27, and then divide both sides by 3. B is going to be minus 9, then, isn't it? Okay, so A is 41, B is minus 9. Question 8. Two identical quarter circles are cut from a rectangle as shown, and we need to work out the shaded area. Okay, so if these are two quarter circles next to each other, then the radius of this quarter circle must be 6 and half of 12. So from here to here must be 6, and from here to here must be 6. Okay, and because this is a circle and 6 is the radius, then this also must be 6, this distance here. So that means the rectangle from which the two quarter circles was cut is of dimensions 12 times 6. So then the area, of the rectangle, which I'm just going to draw a rectangle like that, area rectangle, that's going to be the 12 times the 6, which is 12 times 6 is 72. Okay, and then I've got my area of a quarter circle. Quarter circle is going to be, well, the area of a circle is pi r squared, isn't it? Pi r squared, but I've only got a quarter circle, so it's a quarter of that. And we know the radius is 6, so it's pi times 6 squared over 4. So I'm just going to type that just as it is into the calculator. So I'm going to type in pi times 6 squared. Just take care when you're dividing by 4. You don't want to divide 6 squared by 4, you want to divide the whole thing. So if you subtotal 36 pi and then divide by 4, we'll get a quarter of pi, which is 9 pi. Okay, so then the shaded area is going to be the area of my rectangle minus 2 lots of the area of the quarter circle, and that is going to be 72 subtract 2 lots of 9 pi. Okay, so 2 lots of 9 pi is 18 pi. So then typing into my calculator 72 subtract 18 pi, that gives me 15.45. Does it ask me to round off in a particular way? Nope. So if it doesn't tell me, I'm just going to round off to 3 significant figures. 15.45 rounds to 15.5, doesn't it? So that's what I'm going to write down. 15.5. Question 9. The diagram shows the position of a tap when off and fully on. The tap is fully on when the angle of turn is 180 degrees. So when it's pointing up, it's off, and when you turn it around to face downwards, it is fully on. So when fully on, water flows out of the tap at 14 litres per minute. The rate at which water flows out is in direct proportion to the angle of turn. So the tap is turned to 135 degrees and water flows into the tank with a capacity of 79.8 litres. Will it take less than 7.5 minutes to fill the tank? You must show your working. Okay, so this is an interesting direct proportion question. We know that the rate of water flow is in direct proportion to the angle of turn. So let's call F the flow, and let's make T be the turn. Okay, so we know then that the flow, F, is in proportion to T, the angle of turn. Okay, so I'm going to say that F little fishy T, which means is proportional to, then I can replace that symbol of proportionality with equals to k lots of t, like that. So f equals kt, where k is the constant we need to find. Now, normally at this point we're given two values that go together so that we can evaluate k. Now, the pair of values that we know that go together are that when it is fully on, then the flow rate is 14 litres per minute. And fully on, we already know, is that the angle of turn is 180 degrees. So in other words, our turn is 180 and our f is 14. Okay? So we know that when t equals 180, f equals 14. So let's sub those two values in. So 14 then is going to be k lots of 180. And that makes k 14 over 180 then, doesn't it? K equals 14 over 180. Does that cancel down? 14 over 180. Cancel down, well, not very much. 7 over 90. Okay, so then the complete equation then. So we're saying this cancels down to 7 over 90. Okay, so the complete equation for this relationship is f is equal to 7 lots of t over 90. Okay, so now we've got a formula that links f and t together. We can find what f is at t at any given t. So we want to know what the flow is here then when the tap is turned to 35 degrees. What is the value of f at that value? Okay, so we're going to write down when f equals 130. Well, sorry, when t is equal to 135, what's f? Okay, then f is going to be 7 lots of 135 over 90, which is 7 times 135 divided by 90. It's 21 over 2. 21 over 2 is what, 10.5? Okay, 10.5 watts. The units is litres per minute, isn't it? So that's 10.5 litres per minute. Okay, running out of space a bit here. So if the flow is 10.5 litres per minute, let's come back up here then. So 10.5 litres per minute. Will it take less than 7.5 minutes to fill the tank? Okay, will it? Well, the capacity of the tank is 79.8 litres and it is filling at 10.5 litres per minute. So if we divide one by the other, we'll find out how long it takes. So time is going to be 79.8 divided by 10.5. So what's that? 79.8 divided by 10.5. That gives me 38 over 5, which is the same thing as 7.6. Takes 7.6 minutes. Will it take less than 7.5 minutes to fill the tank? Well, 0.6 is more than half a minute, isn't it? So my answer is no. It takes longer than 7.5 mins. Okay, that's our answer. Now it isn't quite in the right place, but you know, the examiner will find it up there. I think that's fine. Let me just underline it there. Maybe put it in a box. Okay, no, it takes longer than 7.5 minutes. I think I've got all my bases covered. Question 10. This triangle is equilateral. Is the perimeter of the triangle greater than 1 meter? You must show your working. Okay, so I've been given 3 sides of an equilateral triangle, but each side has been given algebraically, and it's a different algebraic expression. So this one is equal to this one is equal to this one. So that means that those 3 algebraic expressions must be equal to each other. So 6x minus 10 has got to be equal to 4x plus 5, which has got to be equal to 10 lots of x minus 4. Okay? Now it's not so easy to work with like 3 parts of an equation like that. Can't really have 2 equal signs. So probably it's easier to work on one part and then the other part. So let's start with the first two. 6x minus 10 is equal to 4x plus 5. So solving those, taking 4x away from both sides is going to give me 2x, and adding 10 to both sides is going to give me 15. So I think 2x is going to be equal to 15, making x equal to 7.5. Now if x is 7.5, what is the perimeter of one side? Okay, so let's take one of those calculations for the side, 6x minus 10 for instance. So what would 6x minus 10 be equal to? That would be now equal to 6 lots of 7.5 minus 10. So 6 times 7.5 gives me 45. And then 45 subtract 10 is going to be 35. So that equals 35. So that side is 35, and because these are all the same, that must be 35, and that must be 35 as well, even if they look a bit different. So the perimeter is going to be 35 plus 35 plus 35, which is 105. Is the perimeter of a triangle greater than 1 meter? Well, it's 105 centimeters, and that is yes. So total perimeter is 35 times 3, which is 105 centimeters. So the answer is yes. 105 centimeters is bigger than 1 meter. It's 1.05 meters, isn't it? Question 11. Now an approximation for the value of pi is given by this kind of strange formula here. 4 lots of 1 minus 22 over 57 plus 22 over 85 plus minus 22 over 105, etc., etc. Use your calculator to show that this approximation is within 0.1 of 3.14. So basically we've just got to type that into the calculator and see what we get. Okay, let's do that then. So calculator, tell me what is 4 minus 1 minus, I'm going to use the fraction key all the way through here, 22 over 57 plus 22 over 85 minus 22 over 105. Notice I'm using the arrow key to get me out of the fraction when I finish typing in, plus 22 over 117 minus 22 over 242, close bracket. What is that equal to then? So I'm going to write down the full display, 3.0418, 3.0148, what's the rest of it? 39619. 39619. Okay, so show that the approximation is within 0.1 of 3.14. So if I then subtract that from 3.14, I should be able to show what the difference is between the two. So 3.14 minus 3.0148399619. What's that going to be equal to then? So on the calculator, 3.14 subtract, don't want to type it in again, just going to use the answer key. That is 0.0816. 0.9816. Okay, which is clearly less than 0.1. Question 12, work out, and I've got two numbers in standard form, 9.12 times 10 to the 10 divided by 3.2 times 10 to the 4. Give your answer in standard form. Okay, now the easiest way to do that is to divide like with like. Now the number part at the front of a number in standard form is called the mantissa. Did you know that? So I'm going to divide the mantissas with each other. And then I'm going to divide the exponent part, which is this part here. So mantissa and exponent it's called. So type in the mantissas in first. 9.12 divided by 3.2. That's going to give me 57 over 2, or 2.85. And then times 10 to the power of what? I've got 10 to the 10 divided by 10 to the 4. I've got numbers with the same base, subtract the indices. 10 subtract 4 is 6. So 2.85 times 10 to the 6. Question 13. Ashraf is going to put boxes into a crate. The crate is a cuboid measuring 2.5 meters by 2 meters by 1.2 meters. Each box is a cube of length 50 centimeters. He does these calculations. Volume of the crate is 2.5 times 2 times 1.2 is 6 meters. Volume of one box is 0.5 times 0.5 times 0.5 equals 0.125. Therefore, the number of boxes is 6 divided by 0.125, and that's 48 boxes. He claims I can put 48 boxes in a crate. Evaluate Ashraf's method and claim. Okay, well, it would make sense what he's doing if the boxes could fit nicely into the crate with no gaps. But I think he's going to have an issue, and the issue is with this measurement here, because that measurement is not a multiple of 0.5. If you have a look at his crate, which is 2.5 meters by 2 meters by 1.2 meters, and think about how many of these little boxes you could stack in that space, he's going to have a bit of an issue in one of the dimensions, isn't he? So let's imagine that this measurement here is the 2 meters, and this is the 2.5 meters, and the height of the box is the 1.2 meters. Okay, so obviously he can fit 4 little cubes going in this direction. 0.5, 0.5, 0.5, 0.5 is equal to 2, and he can put 5 little boxes in this direction. 0.5 times 5 is 2.5, but in the 1.2 direction he's going to be able to fit 1, 2, and then part of a box. So this part here he's not going to be able to fill up. So it's going to be empty space in the box, and that's kind of the flaw in his thinking, really. So how can we put that down in words? So I'm going to evaluate his method by saying 1.2 meters is not divisible by, well, it's 50 centimeters, isn't it? So there's going to be some space. Empty space in the box. So there will be some empty space in the box. So how many boxes can he actually fit in? So thinking about what I've just done here, I've said that he can fit 4 boxes in this direction, and he can fit 5 boxes in this direction, and I think he can only fit 2 stacked on top of each other upwards. So he's going to actually be able to fit in. So he can only fit in 4 times 5 times 2. 5 2s are 10, 4 10s are 40, 40 boxes. Okay, so it can only fit 40 boxes in there and not 48. Not 48. Okay, so I had to do 2 things. I had to evaluate Ashraf's method. So this is my evaluation, and I have evaluated his claim and shown it not to be the case. So I've done that part there. Okay, it's only 2 marks, so I think I've done enough. Question 14. The cross section of a prism has n sides. circle the expression for the number of edges of the prism. Is it 2n, 3n, n plus 2, or is it 2n plus 3? Okay, let's just think about an example first. If I had n is equal to 4, so a four-sided cross-section, otherwise it's some kind of cuboid, then those bits would all be straight, wouldn't they? And then the pattern would repeat at the end. So how many edges would I have? I'd have my n edges, my 4 edges around here, and then I'd have an edge for each of those lines heading that way for each of my 4 corners, plus I'd have another 4 edges down at that end. Okay, so I get 4 plus 4 plus 4, 3 lots of 4. Okay, now if I then had 5, so it was like a pentagonal prism, same thing, and then that went down like that, and I had another pentagon at the back. Can't draw pentagons very well, but you can see again, I'd have, there are my 5, and there's 5 here, so I'm going to have 5 edges on the front face. I'm going to have 5 edges running between them, and I'm going to have another 5 edges on the back face. So basically, it's going to be 3 times the number of corners on my front face, isn't it? So whatever n is, the answer of the number of edges is going to be 3n. Question 15. The volume of a medal is 45 cubic centimeters. The medal is made from copper and tin, and the volume of copper to the volume of tin is in the ratio of 22 to 3. The density of the copper is 8.96 grams per cubic centimeter, and the density of the tin is 7.31 grams per cubic centimeter. Work out the mass of the medal. Ooh, okay, this is an interesting problem. Okay, so let's start at the top. We've been given the volume of the medal, it's 45, and we know it's divided up in the ratio of 22 to 3. So let's divide up that volume into the 2 ratios then. So my 45, I'm going to split into a ratio of 22 to 3. So basically I'm dividing a number by a ratio, aren't I? So taking my 22 parts and my 3 parts and adding it together, I'm going to get 25 parts. Dividing my 25 parts into my total volume, that is going to be 45 over 25. What's that then? 45 divided by 25 is 9/5 or 1.8. Okay, so then this one down here I'm going to multiply by 1.8, and this I'm going to multiply by 1.8. So 22 lots of 1.8. 22 times 1.8 gives me 39.6. So this one is going to have a volume of 39.6 cubic centimeters. So that's the volume of copper, isn't it? That's copper. And on this side, we're looking at tin. So 3 parts tin, 1.8 per part. 3 times 1.8 gives me 5.4 cubic centimeters of tin. Okay. Now, we know the density of copper. It's 8.96 grams per cubic centimeter. And we know the volume of copper. So we should be able to work out its mass. I know that density is equal to mass divided by volume, isn't it? Density equals mass divided by volume. But in this case, I know the density and I know the volume. I want the mass. So mass is going to be rearranging that, moving that up there. Look, I'm going to get mass is equal to density multiplied by volume. So here I know the density is 8.96 for copper, 8.96, and my volume is 39.6. So my copper mass, let's make this copper mass, is going to be those two multiplied together. 8.96 times by 39.6. That comes out to be 354.816. 354.816. I'm just going to write down all the digits for now. And then this side I'm going to work out the mass of the tin. So the tin mass, what's that going to be then? So I know that for the tin, I've got a density of 7.31 grams per cubic centimeters. And we worked out that we had 5.4 cubic centimeters of that. So again, multiplying those two numbers together. So my density of 7.31 grams per cubic centimeter multiplied by my 5.4 cubic centimeters of tin. What's that going to give me? 7.31 times 5.4. It's going to give me 39.474. Okay, so then the total mass then is going to be those two added together then. Total mass is 354.819 plus 39.474. So adding those together, plus 354.819. That comes out to be 394.293. Just going to round that off to three significant figures now. Going to use the first three digits then, 394 grams. It's close enough. Question 16. The cumulative frequency graph shows information about the masses of 50 apples. So we've got the mass of apples along the bottom, and we've got that distinctive S-shaped curve for cumulative frequency at the side. Okay. Use the graph to estimate the median mass of apples. Now, median is middle, and if we've got 50 apples, then the median value, well, normally you would add 1 and divide by 2 to find the median, so 50 plus 1, 51 divided by 2, 25.5, but on a scale like this, you might as well just use the top value of your cumulative frequency, because it doesn't make a lot of difference. Looking up at 25.5 or 25 doesn't make a great deal of difference in this graph, so you're allowed to just use the 50, divide it by 2, and then use that as your lookup value. Okay, so getting a ruler out, finding 25, half of 50 on the cumulative frequency scale. It's there. Okay, and then carefully reading across to the curve, and then changing direction. And then reading down. You can see I end up down here. What's that? It's one little square up from 105. Now there are 5 little squares between 105 and 110, so each square must be 1. So I reckon that's 106 grams. So I'm going to say my estimate for the median mass of apples is 106 grams. Okay, now marking the graph like this is good method, so it's good to draw it on the graph as evidence of your working. Okay, so next part says estimate the proportion of apples that have a mass greater than 115 grams. Okay, so here we're going to use the graph the other way around. We can find 115 grams on the graph, and this time we're going to read up to the curve and across. So just going to switch color pens. So reading up from 115 up to the curve, switch directions, and then read over to the cumulative frequency scale. You can see that ends up there. Go away, ruler. So what's this scale? I've got 10 little squares between 40 and 50, so again each one must be 1. So I'm reading that as 42. Okay, so that value there is 42, but is that the answer to my question? It says estimate the proportion of apples that have a mass greater than 115 grams. This actually tells me that there are 42 apples that have a mass of 115 grams or less. So this tells me kind of this area down here actually. I don't want that area though. I want to know how many apples are more than that. So I have to take 42 away from 50, and that will tell me how many apples are greater than that weight. So 50 subtract 42 is my answer. So it's going to be 50 subtract 42, which is 8 apples. Question 17. A is a prime number, B is an even number, n equals a squared plus ab. Circle the correct statement about n. Could it be even or odd? Is it always even? Is it always prime? Or is it always odd? Now, prime numbers. What are the prime numbers? We've got 2, 3, 5, 7, 11, and so on. So they're mostly odd, but we do have this one even prime number that often causes problems. And what are even numbers? The even numbers are numbers like 2, 4, 6, 8, etc. Okay, so before we get stuck into a problem like this, it's usually good to think about some numerical examples and just double check. Okay, just think about the different sorts of numbers you got in each group and try them out in the expression and see what sort of things happen. So if a, which is the prime number, was my even prime number 2, and I don't know, let's make b equal 2 as well, then my n is going to be 2 squared plus 2 lots of 2 then, isn't it? Okay, 2 squared is 4, 2 lots of 2 is 4, that is going to be equal to 8. Okay, what about if a is another one of my sorts of numbers? Maybe it's one of my odd primes, which most of them are. So what about if a was 3 and b was 2? What would happen then? So if a was 3 and b was 2, then a squared would be 3 squared, and a times b would be 3 times 2, wouldn't it? So that would give me 6 plus 9. 6 plus 9, 15. Okay? So it's definitely not always even because I found an odd solution. It's definitely not always odd because I found an even solution. It's definitely not always prime because 8 is not a prime number. So the only one that really fits then is it could be odd or it could be even. Question 18. A bag contains 20 discs, 10 are red, 7 are blue, and 3 are green. Marnie takes a disc at random before putting it back in the bag. Then Nick then takes a disc at random before putting it back in the bag. Ollie then takes a disc at random. Work out the probability that they all take the red disc. Okay, so we've got selection with replacement here, which means the probabilities stay the same all the way through. It's independent probability, isn't it? It's not dependent, where the number of discs decreases through each selection, because we're always putting the disc back in on all of the selections, aren't we? So on every selection, there's always going to be 10 red, there are always going to be 7 blue, and there are always going to be 3 green. Okay, so work out the probability that they all take a red disc. Well, that's going to be constant throughout, isn't it? There are 20 discs, 10 are red, and there are always going to be 10 red and 20 discs altogether. So the probability on any selection is going to be 10 out of 20. Okay, and then I'm going to be doing that 3 times over, aren't I? So the probability that they all get that is cubing it. So 10 out of 20 cubed. Well, 10 out of 20 is the same thing as 1 over 2, or half. So it's basically a half times a half, which is 1 in 8. So 1/8. 18b. All 20 discs are in the bag. Reggie takes 3 discs at random, one after the other. After he takes a disc, he does not put it back in the bag. Okay, Reggie's first disc is blue. Work out the probability that all 3 discs are different colours. Okay. So we know his first disc is blue, so I'm just going to ignore that first selection. I'm just going to assume I've got 1 less disc and 1 less blue disc in the bag. Okay, so I'm going to start off with 19 discs. 10 of which are red, because none of the red ones have been selected. How many of the other ones were there? 7 blue and 3 green to start with. So if we selected a blue one already, we've got 6 blue left and we've got 3 green ones. Okay, so I've got 19 discs, 10 red, 6 blue, 3 green. So for my second selection, I'm interested in the probability that all 3 discs are different colours. So in other words, it doesn't pick blue again then, I suppose. So what could happen? I could pick red or green or blue on the second selection, and I could pick red or green or blue, or red or green or blue, or red or green or blue on my second, which would actually be the third selection, wouldn't it? Okay. So what are the probabilities along each of those arms? So to start off with, there are 10 red, and out of 19 there are 3 green out of 19, and there are 6 blue out of 19. Okay, now we're not interested in the blue path, because if I went down the blue path I would have 2 blues, because I've already picked a blue on the first selection. So it means that either I'm going to pick the red route, and then I'm not going to pick the red because I'd have 2 reds. I'm not going to pick the blue because then I'd have 2 blues. I must have to pick the green route if I went in that direction. Or on my second selection, I could select the green one, not the blue one, because I'd have 2 blues. And then I'd have to pick the red one, wouldn't I? Because if I picked the green, I'd have 2 greens, and if I picked the blue, I'd have 2 blues. So it's those 2 routes basically. So we want the probability then, probability that they are 3 different colours is going to be the probability then of picking red followed by green, or, which means add in probability of green followed by red. Okay, now I know the probability of red on that selection was 10 over 19. Okay, so now there must be 18 discs left, all of the green ones are left. So that green branch there should be 3 out of 18 then. Okay, so then multiply that by 3 out of 18. Plus, if I went down the green route on my second selection, that has a probability of 3 over 19. And then the red route, there would still be 10 red ones left out of a total of 18. So that's going to be times 10 over 18. Okay, so I've got 10 19ths times 3 18ths plus 3 19ths times 10 18ths. So what's 19 times 18? 19 times 18 is 342. Okay, so I'm going to have 2 fractions over 342. 10 times 3 is 30. 3 times 10 is 30. So that's going to give me 60 over 342 as my final answer then. That's the probability. 60 chances in 342. Question 19. We've got a sign here. It says lunch. Choose 1 starter and 1 main course. There are 4 starters and 10 main courses to choose from. 2 of the starters and 3 of the main courses are suitable for vegans. What percentage of the possible lunches have both courses suitable for vegans? Okay, so how many different selections there are altogether? I've got my 4 starters and my 10 main courses, which gives me 40 different choices altogether. Okay, however, from those, only 2 of the starters and 3 of the main courses are for vegans. So the vegan choices are restricted to 6 out of those 40 dishes. So what fraction then are going to be vegan? So that's vegan, and that's all, isn't it? Okay, so the fraction that is vegan is going to be 6 dishes out of 40 dishes, which is 6 divided by 40, that is 0.15 as a decimal, which is what as a percentage then? 15%. Question 20. N is a positive integer. Prove algebraically that 2n squared times 3 over n plus 6n lots of n squared minus 1 is a cube number. Ooh, okay, let's give it a go then. Where to start? I suppose we could start by multiplying out these brackets, couldn't we? And then have a look at what we've got. Okay, so they look pretty horrendous, but let's see what we get. 2n squared times 3 over n. Well, 2 times 3 is 6. So I'm going to get 6 is my kind of coefficient. And then I've got n squared times 1 over n, which is basically n squared divided by n, isn't it? So that's going to give me 6n. And then if I multiply 2n squared by n, I'm going to get 2n cubed. Plus, what am I going to get from the second bracket? 6n times n squared, that's going to give me 6n cubed. And then I'm going to get 6n times minus 1, which is minus 6n. Okay? So I can immediately see I've got a 6n at the front and a 6n at the back with different signs. They're going to cancel each other out. And that leaves me with 2n cubed plus 6n cubed, which is 8n cubed. Okay? Now, a is a cube number. A is 2 cubed. So I could rewrite 8 as 2 cubed, in which case I've got 2 cubed n cubed. And 2 cubed n cubed is the same thing as 2n all cubed, isn't it? Index of an index. If you have something in a bracket like that and raised to a power, you have to raise each thing inside the bracket to that power. So it's 2n all cubed. In other words, the answer has to be a cube number, because whatever n is, you're going to end up with doubling it and then cubing it, which is going to be a cube number. So therefore, always a cube number. Ta-ta! Question 21 is our second proportion question on the paper. Y is inversely proportional to the root of x this time, and we're told that y equals 4 when x equals 9, so it's a much more straightforward proportion question. So starting off with what we've been given y is inversely proportional to the root of x, so y equal fishy over 1 over root x, like that then. Inversely proportional means 1 over, so y is inversely proportional to the root of x, is written like that. Okay, then we can replace the little fishy symbol with equals k, so then that becomes y is equal to k lot over root x. Okay, then at this point we search for the pair of values that go together so we can evaluate k, and here I've got y equals 4 and x is 9. So when y equals 4, x is equal to 9, that allows us to evaluate what k is. So that means that 4 is equal to k over the root of 9. Now the root of 9 is 3, and then so that means that 4 equals k over 3, and then cross multiplying that 3 over there tells me that k is equal to 12. So the complete equation linking y and x is going to be y is equal to 12 over the root of x. Just replacing what I found to be k in my equation that I worked out earlier. Okay, y equals 12 over root x. Okay, now part B, it says work out the value of y when x is 25. Okay, so that's fairly easy. We just need to sub in then into our equation that we just found. So when x equals 25, then y is going to be 12 over the root of 25. Root of 25 is 5. So basically y is 12 over 5 then, isn't it? 12 fifths, which is 24 tenths, which is 2.4, isn't it? 2.4. So the answer is 2.4. Question 25. Simplify fully x to the power of 5 minus 4x cubed all over 3x minus 6. So we've got an algebraic fraction that we want to try and simplify down a little bit. Okay. Now it looks fairly horrendous to start with. Perhaps you don't really know much about power 5 and power 3 expressions, but these two terms actually have quite a lot in common. They have x cubed in common, haven't they? X to the power 5 is x cubed times x squared. So I can take out x cubed as a common factor. So I'm going to remove x cubed from these two terms and see what's left over. X cubed times x squared is x to the power 5. And x cubed times negative 4 is minus 4x cubed. So actually that's what I've got. Okay, now do you recognize what's inside the bracket there? That's what we call the difference of two squares, isn't it? So you should remember how to factorize those. So factorizing the difference of two squares, you're going to get the root of the first term minus the root of the second term, and then root of the first term plus the root of the second term. Should be x minus 2, x plus 2. Okay. The bottom part have both got 3 in common, so let's factorize that out as well. So that's 3 lots of x minus 2 then on the bottom, factorizing 3 out of both terms. Now you should be able to see that my top and bottom of my fraction are both all in factor forms. So something times something times something, and then that means I can cancel then common factors top and bottom. So I've got an x minus 2 on the top and an x minus 2 on the bottom. They're going to cancel each other out. And what have I got left with then? So I've got x cubed left, and I've got a x plus 2 left, and on the bottom I've got a 3 left, and that's it. So x cubed, x plus 2 on the top, all over 3. Question 23. PQR is a straight line, and we're told that the ratio of P to Q to R is in the ratio of 3 to 1. Which basically means this part of the line is 3 times bigger than this part of the line, isn't it? Okay, and we know that P to Q is the vector A. So what is the vector R to Q? Okay, so P to Q is the vector A. So this vector here is A. Okay, now R to Q, this vector, is going in the opposite direction to A, and it's a third as big as A. So it's going to be minus 1/3 of A. Question 24. Here is a sketch of y equals f of x. The curve passes through the points minus 2, minus 10, minus 1, minus 3, 0, minus 2, 1, minus 1, and 2, 6. Okay, so it looks like a kind of a cubic curve to me. What do we need to know? On the grid, sketch the curve y equals f of x plus 2. Okay. So we've got a transformation of graphs question here. So if we've got our original graph, which is y is equal to some function of x, and it goes to a new graph, which is y equals some function of x plus 2, then that is a translation of 2 units. Well, it's actually minus 2 units in the direction of x. In other words, it's moving 2 units to the left. Okay, so what we're going to do is we're going to take every point on this curve that we know, all the reference points, and we're going to plot them 2 units to the left. Okay, so that first point there at minus 2, minus 10, this point here, that's going to move 2 units to the left. So that's going to put it at minus 4, minus 10. Okay, the next point along, which is the point minus 1, minus 3, this point here is going to move 2 units to the left. It's going to move to there. The next point is at 0, minus 2. That's going to move 2 points to the left there. The next point is minus 1, minus 1 is that point. It's going to move to there. And then I've got the one at the top, and that's going to move to there. Okay, so now I've got all my points. I'm going to join them up with a smooth curve, which should look fairly similar to the one I've been given. Okay, so you can see it kind of does that. And then goes up to that point up there. Okay, reasonably happy with that. Probably could have been a bit more similar in the middle, but okay, it's good enough, I think. I've linked all the points together. I'm not going to bother redrawing it. I think it's good enough to get the marks. Okay, so on the grid, sketch the curve. I've sketched it. All done. Let's move on. Question 25. ABC and ACD are triangles. Work out the size of angle X. Okay, so we've got triangles, we've got sides, we've got angles. So this is going to be something to do with trigonometry. Okay, now we've got a right angle triangle down here. ACD is a right angle triangle, so we can use trig and right angle triangles there. Plus, we've got a non-right angle triangles here, so I think we're probably going to have to use the sine rule or the cosine rule there, I should imagine, to find our missing angle. Let's find out what we need to do. Okay, I suggest we start with the right angle triangle, ACD. What can we do? If in triangle ACD, what do I want to find out? I want to find angle X. So, to find X, I think probably what I need to do is try and find this length first, AC. Because if I know AC, then I can use the sine rule. Let's say I know what this length is here. Then I can use this given side and this angle, which goes together in a pair, and this side I would have just found along with this angle, and then I can use the sine rule, because sine rule is about opposite pairs that go together, isn't it? Okay, so I could use the sine rule if I can work out AC. So in triangle ACD, in the right angle triangle, I'm going to use normal trig to find AC, and then I'm going to use the sine rule to find X at B. Okay, so that's my plan of action. Okay, so let's kick it off. So in triangle ACD to start off with, and sometimes it's good just to sketch the triangle that you are using. So I know that's 16, ACD, that's 49, that's the right angle, and I want to know what AC is, don't I? So what have I got? I've got an angle, I've been given the adjacent, and I want the opposite, don't I? That's the hypotenuse, not interested in that. So I want to know about the opposite, and I know the adjacent. So because I know SOHCAHTOA, that's my way of remembering which way round it goes. I want the opposite from the adjacent, so it's the tan part I'm looking for. So tan theta equals opposite over adjacent. That's the trig ratio for tan. Subbing in what I know, so I know that tan 49 in the angle is equal to the opposite, which is AC, that's what I'm trying to find, divided by the adjacent, which is 16. So that means that AC must be 16 tan 49. Okay, and according to my calculator, 16 tan 49 is 18.4 and change. Okay, I'm going to write down 18.4, but I'm going to leave that value in my calculator so I don't lose accuracy. So 18.4 centimeters. Okay, so now I know AC, I can then go on to use the sine rule in triangle ABC then, can't I? So I'm going to switch now to in triangle ABC. Let's quickly sketch that out as well. So I've got my triangle, looks a bit like, looks a bit like this. What do I know? I know the 35-degree angle down there. I know that that's AC, and that is 18.4. I want that angle up there, that's X. And what are the sides? B, A, and C. So B, A, and C are like that, aren't they? Okay. I know something else as well, don't I? Oh, I know that BA is 20. Okay, so I'm going to use the sine rule, using sine rule. So it's about opposites. A over sine A equals B over sine B is equal to C over sine C, or the other way around. I want sine B over B is equal to sine C over C, I think, that way around, because I want to know the angle. I'm going to start with the angles at the top then. So sine B over B is equal to sine C over C. Now the way we label these up is that the ones opposite, the sides opposite the named letters of my sides are the lowercase version. So that's C there. And AC is going to be my B in this case. Okay, so now I know what to sub in. So sine B is my X angle. So sine X divided by B, which is my calculated value from earlier, 18.4. And that's going to be equal to sine C, which is the sine of 35, divided by my side C, which is 20. So rearranging that for X, I'm going to get sine X is equal to 18.4 sine 35 over 20. All I've done is kind of cross multiplied that up there, haven't I? Okay, so sine X equals 18.4 sine 35 over 20. And what I then want to do is inverse sine that then to find the answer. So I want the inverse sine to get X from there. So that's going to be sine to the minus 1 of that then, isn't it? 18.4 sine 35 over 20. Okay, that's what I'm going to type into my calculator then. So shift sine to the minus 1 of 18.4. I'm going to use the last calculated value, so I'm going to use the answer key, so I don't lose accuracy. Sine 35, and then divide that by 20, and I want to find the inverse sine of all that. So apparently that is 31.86, which I'm going to round off to one decimal place. I'm going to say that's 31.9. 31.9, these are degrees, isn't it? Because it's an angle. So X equals 31.9. Just right on the line there. Okay, 31.9. Question 26, f of x equals x over x plus 2 and g of x equals x squared minus 2. Work out f of g of x. Give your answer in the form a plus b x to the power n, where a, b, and n are integers. Okay. So basically, I've got to take function g and sub it into function f. You kind of work from the inside out for these. So closest to the x is this g here. So that means I've got to take this expression for g and I'm going to sub it into f. Okay, it's going to go into f. So I'm going to rewrite this expression wherever I see x in this expression. Okay, so that's the plan anyway. So fg of x is going to be x, but this time I'm going to replace x with x squared minus 2. So writing x squared minus 2 where the x used to be, divided by, I've got another x down there, so I've got another x squared minus 2 plus 2, because that was there before. Okay, so just removing the brackets. So I've got x squared minus 2 on the top, divided by x squared minus 2 plus 2, which is just x squared. Okay, now it's not quite in the form we need it in. We need it in the form a plus b lots of x to the power of n. Okay, where I've got a fraction over x squared at the moment. Okay, so I'm going to break this up into, I've got an algebraic fraction, I'm going to break it up into 2 halves. So x squared minus 2 over x squared is the same thing as x squared over x squared minus 2 over x squared. Okay, now x squared over x squared is just 1, isn't it? Anything divided by itself is 1. And I've got minus 2x squared. Now I can rewrite that as a negative index. I can say that that is equal to 2x to the minus 2. Okay, using negative indices. And now I've kind of got it in the form I wanted it to be in. Okay, so having a look back up at the top there, look. A is now my 1. b is my -2, and n is my -2 up there as well. Okay, so I've got integers for all those. It's all in the right form. I'm good. Let's move on. Right, question 27. The point 3, 1/64 lies on the curve y equals k to the power of x, where k is a constant. Show that the point 1/2 lies on the curve. Okay, now this is what we call an exponential curve, and exponential curves always look like this. Okay, they look like a curve that looks like that. You should know your graph types. Know what that value is there? It's going to be 1, because at that point x is 0 and anything raised to the power of 0 is 1. So it always goes through 1 there. Left of the y-axis, you can see it's getting smaller and smaller and smaller, approaching 0 but never touching. And right of the y-axis, it is increasing, so getting steeper and steeper and steeper. Okay, so where is the point 1/2? Show the point 1/2 lies on the curve. Okay, so that clearly isn't the right way of drawing this, is it? Because so this isn't quite the right graph form for this, is it? Because if we look to the right where half would be on my scale, it's clearly above 1, so that doesn't look quite right. Now you can get these sort of graphs kind of inverted, looking more like, oops, that was very badly drawn. You can get these graphs kind of reflected and looking more like that, so decreasing as x increases, kind of a reflection in the y-axis. So you can get graphs appearing this way around if this constant here, k, happens to be a fraction. That's when you get it flipped around like that. Okay, let's see if we can evaluate what k is anyway. So we know we've been given a point which lies on the line up here, look. Oops. We know that when x is 3, y is 1/64. So when x equals 3, y is 1/64. So subbing that in, that means 1/64, y is equal to k lots, k to the power of x, which is 3. So k cubed is 1/64. So to find k, we need to find the cube root of both sides, don't we? So what is the cube root of 1/64? The cube root of 1/64 is k then, isn't it? So what's the cube root of 1/64? Well, 64 is 4 cubed, so the cube root of 1/64 is 1/4, so k is 1/4. Okay, so that means that the equation of my line then is going to be y is equal to 1/4 to the power of x. Okay, so y equals 1/4 of x. So show that the point 1/2 lies on the line. Now we can do that by subbing in x equals 1/2 and showing that that's equal to 1/2 then for y. Okay, so when x equals 1/2, then y is going to be 1/4 raised to the power of 1/2. Okay, well, if you raise something to a fractional power, to power 1/2, that's the same thing as finding the square root, isn't it? Raising the power of 1/2 is finding the square root. So actually y is going to be the root of the square root of 1/4, and the square root of 1/4 is 1/2. So y is equal to 1/2. So therefore 1/2 lies on the line. Okay. Question 28. Izzy runs an 80-meter race in 14 seconds. During her first 6 seconds, her speed increases at a constant rate. During her last 8 seconds, her speed increases at a different constant rate. Her speed at 14 seconds is 2 meters per second more than her speed at 6 seconds. Here is a sketch of her speed time graph. And question 28a says, work out her acceleration during the last 8 seconds. Okay. Now the last 8 seconds is, well, it's the time from 6 to 14, isn't it? That's 8 seconds long. So we're talking about this section of the curve, of the graph here. And acceleration is equivalent to the gradient on a speed time graph. So acceleration equals gradient at that point. Okay, now I don't know how fast she was going at time 6, let's call it x, but I do know that at time 14 she was going 2 seconds more, 2 meters per second more than her speed at 6 seconds. So if this value was x, then this value is x plus 2, which means that distance between there and there must be 2. Okay, so I don't know what x is, but I know that that one up there is 2 more. So I do know the change in y. The change in x is just 14 minus 6, that's 8, isn't it? So the acceleration is going to be the change in y, 2, divided by the change in x, 8, which is the same thing as a quarter, or 0.25. State the units of your answer. Okay, well, we're using meters per second. So then the speed is going, so the acceleration is going to be 0.25 meters per second, or ms to the minus 2. Okay. Okay, what's part B say? When Izzy finishes the 80-meter race, her speed is v. Work out the value of v. Okay, so we actually need to then work out what this value up here is going to be. So this thing earlier I called x plus 2, that's going to be the v that I need to find then, isn't it? Okay, right, so how am I going to find that then? Well, the only other information on this question that I haven't used yet is this, the fact that Izzy runs an 80-meter race in 14 seconds. Now, I know that the area under a speed time graph is equal to the distance traveled. So if I can find the area under the graph, that might give me some clues about how to find v. Okay, so breaking up my graph into 2 distinct areas, I've got a triangle down here and I've got a trapezium. Okay, now let's say that the speed at, we said was x, wasn't it? So the area of this first triangle then is half base times height. So this bit here is going to be a half base height, which is equal to a half times the baseline, which is 6, times a height, which we called x. So half times 6 times x. That means this has an area of 3x, doesn't it? Okay, so the triangle is an area of 3x. What about the trapezium? Now a trapezium, oops, come back. A trapezium, it has a formula half a plus b h. Okay, so where a and b are the 2 parallel sides. Okay, so my first parallel side, this one, we already know is x, and my other parallel side, this one, we called x plus 2. X plus 2 times h is the distance between them, isn't it? So that distance there, which we know is 8. Okay, so what's the area of that then? Half 8 is 4. X plus 2 is 2x plus 2. Half 8 is 4 times 4. So just multiplying everything in the bracket by 4, I'm going to get 8x plus 8 then, isn't it? So that area is 8x plus 8. So the combined area then is 3x plus 8x plus 8. Okay? So, distance equals area under graph. So our 80 meters is equal to my 3x, my triangle, plus my 8x plus 8, my trapezium. So 80 then is equal to 11x plus 8. Okay, so what's that then? Taking 8 off both sides, 72 equals 11x, dividing through by 11. X then is going to be 72 over 11. Okay, So x is 72 over 11. Remember I wanted to find v though, which is x plus 2. So I need to add 2 to that. So v then, v is equal to, oh, should really do it down here I suppose. So v is equal to my x plus 2. So I said it was 72 over 11 plus 2 then. So what is 72 over 11 plus 2? 72 over 11 plus 2, that's 94 over 11. What's that then? 8.54 reoccurring. So 8.5454, I'm just going to round that off then to 8.55 meters per second then, isn't it? Because it's velocity. 8.55. So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.